We saw in an earlier video that the Laplace transform of a derivative can be calculated as the Laplace transform of the derivative of a function, in this case y, is s times the Laplace transform of that function minus that function at 0. Now, what about higher order differential equations? In this course, we've already studied second order differential equations. Here, we'll use what we know about the Laplace transform of y prime to find the Laplace transform of y double prime. Since y double prime is the derivative of y prime, we can compute its Laplace transform as the Laplace transform of y double prime is the Laplace transform of the derivative of y prime, which can be found as s times the Laplace transform of y prime minus y prime at 0. This is because we're computing the Laplace transform of a derivative. So its Laplace transform is s times the Laplace transform of the function whose derivative we're taking, in this case y prime, minus y prime at 0. Now, we also know the Laplace transform of y prime. That we wrote above. The Laplace transform of y prime is s times the Laplace transform of y minus y at 0. So by replacing this in our formula for Laplace transform of y double prime, we have s times the Laplace transform of y prime, which itself is s times the Laplace transform of y minus y of 0, all minus y prime at 0. So, distributing the s, we can conclude that the Laplace transform of y double prime is s squared times the Laplace transform of y minus s times y at 0 minus y prime at 0. So now we know how to compute the Laplace transform of y double prime. And I want to note that we can repeat this process for higher level derivatives as well. In general, the Laplace transform of the nth derivative of y will be s to the n times the Laplace transform of y minus s to the n minus 1 times y of 0 times s to the n minus 2 times the first derivative of y at 0, all the way down the line until we get to the n minus first derivative of y evaluated at 0.